this presentation. Today we will present the key design decision contrasted against the relational database that leads to active embracing of eventually consistent reads. In this presentation, our speaker order will be Lin Xi and Florian Suez. Along with the rapid development of technology, our screens are getting smaller and smaller, but the amount of data we generate is getting larger and larger. In 2022, a statistic estimation showing that the world would produce and consume 94 zettabytes, and this number could be reached to 194 zettabytes in 2024. In fact, a person on the internet produces 1.7 megabytes per second, and that is 146,880 megabytes per day. Behind those crazy numbers, all because of the evolution on how business is running. Running all business online requires the data store evolutions too. Instead of using paper files as the system of record, the database as a new system of record becomes the most critical components in a business firm. Almost all organizations, including governments, are undergoing or have undergone this massive digitizing process. George Westerman, the author of the book Leading Digital Turning Technology into Business Transformation, says those organizations who have successfully used technology to transform their business have 26% high profit margins than their peers. Storing and providing data, collecting and analyzing data, and providing scientific findings for business decisions are essential factors in the success of these organizations. Relational database and NoSQL database are two different types of database, and they also compete with each other. In the 1980s, the Golden 12 rules introduced by Edgar Code provided essential criteria for relational database. A relational database is a database that uses a relational model to organize data. This normalized two-dimensional table structure of data storage is very close to the real world, which is easier for developer to understand the data. The common SQL language makes it much easier to manipulate database. The database ACID characters also significantly reduce the probability of data redundancy and data inconsistency. The most significant advantage of the relational database is the consistency of transaction, which is a feature that allows relational database to be applied to all the systems that require strong consistency. For instance, banking system. However, as we said previously, we are living in a world where everything is data and everything is connected. To handle this new reality, organizations need to scalability and elasticity. Unfortunately, a relational database wasn't designed for this. Some distinctive features of the relational database become the bottleneck when handling high availability and high concurrency situation. Achieving scalability and elasticity is a huge challenge for relational database. Relational databases were designed in a period when data could be kept small, neat, and orderly, but that has been changed. The data now is pumped in from everywhere, and a massive amount of data increases the cost of filtering data. And as the cost of the storage drops, organizations need to store just about everything. In most organizations, the structured data costs the bulk of the overhead. This is because relational database has trouble with managing data that isn't uniform. A relational database needs to pre-define schemas before loading data. Any changes required to handle a new data source are cumbersome and increase schema complexity. The easiest and faster way to solve this issue temporarily is to set up another database, which causes the severe problem of data silos. On the other hand, even if we ignore the problem of infinitely increasing schema complexity, still, the relational database cannot simply add more hardware and service node to expand the performance and load capacity like a web server. In other words, the horizontal scale is not suitable for the relational database. It is possible, but takes lots of maintenance efforts. Horizontal scaling of database is splitting row-wise into multiple tables to reduce the time taken to fetch data. Tables in relational database are normalized into multiple tables of related data. In order to shard data of such a table on multiple machines, you would need to shard related normalized data accordingly, which would increase maintenance effort. For example, let's say we have a customer table and an order table. The customer table is related one-to-many relations with order table. If you move some rows of customer table or customer data onto another machine, you will also need to move its related order data onto the same machine, which will be a troublesome task in the case of multiple related tables. An alternative way is providing the join feature from client-side code, but this would mean you have to access database multiple times from multiple shardings. This will also bring more complexity to client-side and add extra load to the database. The CAP theorem explains this phenomenon very well. When scaling relational database horizontally, it's essentially a game between consistency and availability. Although many database providers have come up with many solutions like MySQL Cluster, PostgreScitos, and Google Spanner, the challenge is to find a balance between usability and consistency. Like or not, partition tolerance is going to happen anyway, so essentially this is a choice between availability and consistency. Unlike horizontal scaling, vertical scaling is a relatively easy way to implement scaling for relational database. We can double up RAM, CPU, and other hardware resources to reduce disk I/O pressure in the face of high concurrency. However, vertical scaling can still not solve the availability issue when error occurs, and hardware extensions are not available indefinitely, especially when we face weird increment of data is much faster than the hardware upgrade.